Yeah, hello everyone. So in this presentation, we propose an interaction prediction network and fused with Monte-Carlo research for solving robot manipulation problems. So robot manipulation is a large topic. In this work, we are mainly focusing on how the non-prehensile manipulation such as pushing could help to solve the problem. We studied two tasks that are common in everyday environments: clutter removal, as shown in left column, that is removing all objects in the workspace. The object retrieval is on the right, which only cares about the target object, that is masked in purple in our experiments. The bottom left video is one example from related work, which trains the DQN to decide when to grasp and push. Instead of just using DQN, we are trying to learn the ability of imagining the outcome of an action before taking it, so that the robot can make smarter decisions. For this purpose, we propose a deep interaction prediction network, which can predict the poses of objects after an arbitrary push action. Then we can generate a clear image for further planning. So our interaction prediction network works as follows. First, DIPN employs mask Cartesian for object segmentation. The resulting binary masks and their centers, one pair object, serve as input to the push prediction module of DIPN. This object's information and push action are passed to the DIPN. The DIPN then predicts the object's 2D transformation. We combine 2 ResNets and 3 multilayer perceptrons for this purpose. Finally, a synthetic image is then generated by applying transformations according to the original image and segments. So we evaluated our method for solving clutter removal tasks in densely packed cases. Because DIPN produces a clear image, we can then apply a grasp network to evaluate the push action to decide whether to grasp or push by comparing the grasp success rate. This is the video of 5 consecutive experiments. So with the visual foresight from DIPN, we can use the Monte-Carlo tree search to find the best action. So let me show you with an example that the object in purple is the target to be retrieved. In the first iteration, the input image is evaluated by a grasp network that shows the target object is not directly graspable. Then a tree will be constructed by fusing Monte-Carlo tree search and DIPN. This fusion generates a tree of multi-step push prediction as graded by the push network. The best promising push is then chosen and performed. So we need a second iteration as a single push is not enough. So after 2 push actions, the target object now can be grasped. Here we show some demo videos on wood bricks. 2 networks are trained in simulation with similar bricks. They work in real world with a negligible performance degradation. The target object is covered by purple masking tape. The visual foresight tree shows the human-like performance. The drawback is the current implementation will take like 2 minutes, the inference time. So this is a benchmark of our method. We have 2 papers on this project. You can find more detail about it. Yes, thank you for listening.
Yeah, thank you, Baichuan. And any questions from audience? Yeah, maybe, yeah, from me. And you mentioned the interaction prediction network, but usually some interactions, we will consider some graphic neural network or convolution neural network, and why you didn't use it. And so what's the disadvantages and the advantages, yeah, compared to the graph neural network, yeah.
So in this task is that we would like to consider about like arbitrary number of objects. So with this directly convolutional, we can, with our implemented ResNet and multilayer perceptron, we can process any number of objects. But with the graph network, we haven't studied actually yet with that.
Okay, thank you. Any other questions? If no, let us thank, oh, another question. Do you know the segments of?
Oh yes, we actually applied a mask Gaussian, so that will extract the segmentations first. Then we will use the masks for the next prediction.
Yeah, no questions, no further questions. Yeah, thank Baichuan again.